Okay, so picture this. It's January 21st, 2026. Just a couple of days ago, you're sitting at your desk, you've got your coffee, and you're, I don't know, scrolling through GitHub.
A normal Tuesday.
A completely normal Tuesday. You're looking for a new library, something to optimize your workflow. And then you stumble on a repo that it shouldn't exist.
Right. It's that moment where you stop scrolling immediately. There's no press release, no flashy marketing video, just raw code out in the wild.
Exactly. And this wasn't some student project. We're talking raw data architecture specs for something called Model 1. And if you've been paying any attention to the whispers on Discord, that name carries a lot of weight.
A massive amount of weight. Model 1 is, for those in the know, the code name for the successor to DeepSeek R1. And that model basically flipped the entire AI industry on its head last year.
So the internet, or at least our very nerdy code-obsessed corner of it, is on fire. So today we're doing a deep dive. Our mission is, well, it's pretty simple. We needed to sift through this leak. We have the academic papers on R1, the predecessor.
We have the actual raw data from the GitHub repo.
And we have verifiable hardware specs. We're going to figure out if this Chinese digital dragon, as the forums are calling it, is a genuine quantum leap, or if it's all just smoke and mirrors.
Yeah. Is it real, or is it just designed to scare the competition?
It's the billion-dollar question. I mean, probably $1 trillion question, actually, given the market caps. But before we get into the nitty-gritty of, attention heads and floating points, and we will get there, let's just set the stakes.
Okay.
Why should you, listening right now, care about some random GitHub leak?
Well, to get that, you have to look back at 2025. Remember when DeepSeek R1 dropped?
Oh, absolutely. It was chaos. My entire feed it melted down.
It shook the stock market.
Yeah.
I mean, before R1, the narrative was so specific. It was, to build a frontier model, you need $10 billion, a warehouse full of GPUs, and like 500 PhDs.
A game for giants only.
Right. And then DeepSeek R1 happened.
And it just upended that entire narrative.
Completely. It proved you could compete for a fraction of the cost. So the question on everyone's mind now is history about to repeat itself? Is Model 1 going to make today's AI look obsolete overnight?
So let's rewind. To understand Model 1, we have to look at where they came from. Who is DeepSeek AI? Because they are not your typical Silicon Valley story.
No, not at all. They didn't start in a garage in Palo Alto. It's a fascinating origin story, actually. DeepSeek AI is a Chinese startup, yes, but the key detail, the one people miss, is their backer. They're funded by a hedge fund called High Flyer Quant.
Which sounds like a villain's organization in a Bond movie.
It does have a ring to it.
Yeah.
But that background is crucial. These aren't VCs throwing money at a dream. These are quants, math nerds. Their entire culture is built on, extreme efficiency and optimization.
They don't throw money at problems, they throw math at them.
Exactly. And you see that DNA all over their AI work. When R1 came out in 2025, the stats, they were just weird. They didn't make sense.
Right, I've got the numbers here. R1 had 671 billion parameters, which is a real heavyweight. But the training costs.
$300,000.
It's just, let that sink in. 300 grand, that's cheaper than a Ferrari.
Yeah.
It's less than a single senior engineer's salary in San Francisco.
And other companies are spending hundreds of millions. And DeepSeek rolls up with a model that costs less than a condo. And that efficiency, that's their whole philosophy. But it wasn't just cheap, it was smart.
How they did it was the real story, wasn't it? The shift to pure reinforcement learning.
Yes, RL, without the initial supervised fine-tuning that everybody else is doing.
Okay, so let's unpack that. Pure reinforcement learning. For someone who isn't a machine learning engineer, how should we visualize what the machine is actually doing?
The best analogy I've seen, and this comes from the research community, is to imagine a student taking a really hard math exam.
Okay, I'm with you. I can feel the stress sweat.
Right. Now, in the old way, supervised learning, the student takes the test, hands it in, and a teacher marks it up with a red pen. Right, wrong. The student learns by memorizing the teacher's corrections.
Okay.
But in pure RL, the student is taking the test. But they can look at their own answers as they go. They write a step, look at it and think, wait, that logic doesn't hold up, and they erase it and try again.
So it's correcting its own exam during the test?
Precisely. It's self-auditing.
Yeah.
And this leads to what they call emergent self-reflection behaviors. The model is essentially teaching itself how to reason.
That's where you get those aha moments where it suddenly just gets a complex problem.
Exactly. Not from memory, but from logic.
Yeah.
And the proof was in the results. R1 didn't just compete on price. It matched OpenAI's O1 model in math. That's 79.8% on the ME benchmarks.
And it hit something like 96.3% on code forces, right? That's better than most human.
It's better than most expert human programmers. And there was this piece in Nature that I think is really key. It highlighted that R1 did not use outputs from rival models.
So it wasn't just, copying OpenAI's homework.
No. This was organic innovation. It proved they were innovating on the method itself.
Which brings us to the leak. January 21st, 2026.
The leak.
A repo appears on GitHub, details on what everyone's calling V4 of their architecture, Model 1. And if R1 was about doing it cheaper, Model 1 seems to be about doing it just better.
The theme is efficiency is the new king.
Yeah.
They're moving away from just raw scale. It's not bigger is better anymore. It's smarter is better.
Let's get under the hood here, the technical specs. First thing that jumps out is the architecture change. Attention heads are reduced from 576 dimensions to 512.
Which is a significant drop.
Now, to a layperson, that sounds like they made it worse, smaller.
You'd think so, right?
Yeah.
Bigger numbers are usually better, but think of it like aerodynamics on a race car. You don't just add a bigger engine. Sometimes you make it faster by shaving off drag. They're cutting out the mathematical fat so the signal travels faster.
Computational aerodynamics? I like that.
But the real magic, the part that has the forms buzzing, is the memory management.
Oh, I loved this part. They're using something called sparse computation with FP8 for KV cache.
It's a mouthful, I know.
But the analogy from the source material is perfect. They described it as being like a strict dietitian.
It's a great comparison.
Compared to older models, which are, and I'm quoting here, millennials with pirated Netflix accounts using resources loosely.
It's funny because it's so accurate. So they KV cache. That's where the AI stores the conversation history, to remember what you said. In older models, that cache gets huge. It's like a digital hoarder.
I might need this sentence from 3 paragraphs ago.
Right. But Model 1, the strict dietitian, uses sparse computation. It aggressively prunes the memory. It looks at the data and says, do I really need to remember the or this and? No. And it throws it out.
Then the FP8 part.
That's 8-bit floating point. It's a way of compressing the data it does keep. So instead of writing it down in high def, it's more like a pencil sketch.
Right.
It takes up way less space, but the model is so good it can still read the sketch perfectly.
So it runs faster on less hardware.
Critically, you don't need a massive server farm if your memory footprint is tiny.
There are a couple of new acronyms in the leak that caught my eye, VVPA and Enneagram.
The new jewels in the tech stack. So VVPA is a mechanism for long contexts. You know how a chatbot sometimes forgets what you said at the start of a long conversation?
Oh, constantly. It's infuriating. I just told you my name.
Right, the goldfish problem. VVPA is designed to prevent that. The docs call it enabling eternal conversations.
Eternal conversations, okay.
And Enneagram.
Enneagram is memory compression. This is huge for developers. It lets the model reason across massive code repositories. Imagine giving an AI your entire company's code base, millions of lines, and just saying, find the bug.
That would usually just crash the model. Too much context.
Exactly. But Enneagram compresses that info so the model can see the whole picture at once.
That is a complete game changer for software engineering.
It really is. And all of this is optimized for the new Blackwell B200 GPUs. The specs in the leak show it hitting 350 TFLOPS in sparse mode.
TFLOPS being trillions of operations per second. Pure speed. It's not just smart, it thinks fast.
So we've got this beast of a model. What does this mean for the industry? I mean, we have OpenAI's O1 as the incumbent.
Right, and the comparison is fascinating. The analogy that keeps popping up is if O1 is a Ferrari.
Okay, fast, sexy, incredibly expensive, high maintenance.
You need a pit crew, a special track. The cost of entry is astronomical.
Then Model 1 is a Tesla.
Exactly. Electric, efficient, accessible. You don't need a Formula One team. You can park it in your garage.
And this feels like it has massive geopolitical implications. We always talk about the U.S. versus China AI race.
We do. And the narrative has been that the U.S. has the hardware advantage because of export controls. The assumption was that choking off the supply of H100s would choke off their innovation.
But Model 1 suggests something else.
It suggests the sanctions paradox. By limiting their hardware, we force them to innovate on software. They can't just throw raw power at the problem, so they have to get smarter.
If you can't buy a bigger engine, you learn to build a lighter car.
Precisely. And now their car is so light and aerodynamic, it might just beat the muscle car with the giant engine.
And the leak also points to them leading on open source.
That's the other part of it. While Western giants are closing their models off, putting them behind paywalls, DeepSeek seems to be challenging that whole model.
There's a lot of chatter on X about an official release. When do we actually get our hands on this thing?
The rumor mill is pointing towards February.
Right in time for the Lunar New Year.
That's the theory. A little New Year's gift to the world's developers. And the prediction is that its coding abilities will surpass both Claude and GPT.
That's a bold claim.
It is, but given that enneagram feature, it's plausible. If you can fit more context in, you can write better code.
Okay, I have to play devil's advocate. This all sounds too good to be true. It's cheap, fast, smarter than everyone. What's the catch? There's always a trade-off.
There is always a catch. And the documentation in the leak does mention some distinct limitations.
Like what?
Well, for one, it's highly sensitive to prompts.
Meaning you have to ask it nicely.
You have to ask it precisely. Because of the way the RL training works, it's a bit temperamental. Change the wording slightly, and you might get a vastly different quality of answer.
That sounds frustrating for a casual user.
It is. It requires a power user touch. There's also this issue they call language mixing.
What's that?
Remember that internal monologue, the chain of thought?
Yeah, the student correcting their own test.
Well, sometimes that student gets confused about what language they're speaking. It might start reasoning in English, switch to Chinese for a complex step because the training data was denser, then output in English again.
It's code switching inside its own head.
Exactly. It gets messy. A Tower of Babel in the machine.
So, brilliant but a bit scattered. What else?
It lacks native tool use.
So it can't browse the web or run code out of the box.
Not natively. It's a brain in a jar. You have to hack in the APIs yourself. It's not a seamless agent like some others are.
And what about safety? That reinforcement learning, letting it teach itself, doesn't that come with risks?
It comes with the big risk of reward hacking, which sounds ominous.
It's a classic AI safety problem. If you train a model to maximize a reward, like getting the right answer, it might find a clever unintended way to get that reward.
Like cheating on the test instead of solving the problem.
Exactly. The genie in a bottle problem. With a model this powerful, teaching itself in real time, how do you guarantee it doesn't learn the wrong lessons? That is the big unanswered question.
So it's powerful, efficient, but maybe a little bit of a wild card.
The digital dragon is still waking up. We don't fully know its temperament yet.
So let's zoom out. What does this all mean for the person listening right now?
I think the summary is that Model 1 represents a move toward democratizing access to superintelligence.
How so?
By crashing the cost. If this efficiency is real, if this sparse computation works as advertised, we could be looking at the end of million-dollar cloud bills for companies wanting to run top-tier AI.
And it proves the competition is real. It's not just one company owning the future.
Absolutely. It validates that the digital dragon has, well, it's awakened. You know, I'm sitting here thinking about that efficiency breakthrough, the strict dietitian memory running on consumer hardware.
It changes the whole landscape.
It really does. And I want to leave our listeners with this thought. For years, we've assumed AI would be this centralized AI god, right? A giant computer in a data center we all plug into.
The oracle on the mountain.
Right. But if Model 1 is real, if AI becomes this cheap and this efficient, if you can run a superintelligence on a high-end gaming PC, are we seeing the end of that whole era?
That is the provocative thought.
Are we at the beginning of personal, pocket-sized supercomputers?
Imagine a world where everyone has their own Einstein,
Mm.
running locally on their device, totally private. Not an oracle on a mountain, but a genius in your pocket.
And that's a very, very different world than the one we're in today.
Indeed it is. That's all the time we have for this deep dive. We'll be keeping a close eye on GitHub for that February release. Thanks for listening, and we'll catch you on the next one.